Hey everybody, my name is Kelvin and welcome back to episode 12 of my Learn Python series. In this video, we're going to be continuing on episode 11, where we covered object-oriented programming principles. Specifically, I'm going to use this episode to help you learn about inheritance. Inheritance is one of the main core ideas in object-oriented programming. It gives us a way to create a new class that is based on an existing class. That means if two classes share some common behavior or data, we do not need to rewrite everything from scratch every time. We can just define the shared parts once in a parent class, and then let the child classes build on top of that. And that's the main purpose of inheritance. Up to this point, we've been making classes on their own. Remember that a class has attributes, methods, and its own internal state. That is already useful, but very often in programming, you run into situations where multiple classes are closely related. For example, maybe you have a general animal class, then maybe you want a dog class and a cat class. A dog and a cat are not the exact same thing, but they do share some common traits. They might both have a name, or they might both have an age. They both might be able to make a sound. So instead of writing all of that common code separately in both classes, we can place the shared parts in a single parent class, and then let the child classes, quote, inherit from it. And that's the idea we're going to be focusing on. Also, real quick before we jump in, if you've been enjoying the content on this channel and want to support what I'm building here, check out my book Modern Data, From Ingestion to Production. It's a practical introduction to how data moves through modern systems, from ingestion and transformation all the way to production use. It's available on Amazon, Barnes & Nobles, and Apple Books, and the ebook is only $6, so it's a really affordable way to support the channel and learn something useful at the same time. Be sure to check out the links in the description. Let's create the exercise folder for today. Create a Lesson 12 folder. In this episode, it'll be easier if we keep all of our code in a single file. So we're only going to create 12-1.py today. I'll be using the animal example to explain inheritance to you today. So to start, we're going to need a class called animal. And we can define it like this from exactly the same way that we covered from last episode. And we'll define an init. Remember, this is the constructor for the class. And it'll take in parameters self, name, and an age. And we can set self.name is equal to name, and self.age is equal to age. In an animal class, it makes sense that we have instance attributes of names and ages. These attributes would be shared by any animal. Now, let's define a method called describe, and it's going to take in self. And what I'll do here is give us the information of name and age in a nice readable format. So print self.name is self.age years old. And that's all it's going to be doing. And let's also define a method class called speak. This will print what sound an animal makes. Since we have a generic animal right now, we'll just have it say a sound. So f self.name makes a sound. This is not speak, this is self right here. And we've defined our animal class. First, it has attributes name, age, and two methods, describe and speak. As you can see, this class is very general. We can't derive any specific animal from these because all animals can make a sound. All animals can have a name or can be however many years old. Now, let's say we want to create a dog class. A dog is trivially an animal, so it makes sense for dog to be related to the animal class. Before we create the dog class, let's test to make sure animal works. We'll create a variable, animal1 is an animal that is some generic animal And let's say they're 5 years old. And here we have two methods: describe and speak. And let's test this. Here we get an error. Animal takes no argument. And taking a look at the code, we see that the init, I miscreated the init. You have to have two underscores on either side. And what I had before was just this. So that was why we get that error. But if we run it now, we can see that we successfully create our generic animal. Now that we got our animal class working, we want to create our dog class. Our dog class is going to inherit from our animal class. And the way we can create that is by doing class dog, and it'll inherit from the animal class. Right, like that. The class inside the parentheses here is the parent class. So animal is the parent class and dog is the child class. At the moment here, this dog class doesn't really define anything new. It just says that dog should inherit from animal. That might look too simple at first, but even with just this code, the dog class already gets access to what's defined in animal. So let's just put a pass in there for now, and we can do dog1 is equal to a dog that is named Buddy, and let's say they're 3 years old. And note that we haven't defined anything in the dog class, but it'll have access to the methods and constructor of the animal class, even if we haven't defined anything in dog. So here we know that dog1 has the method describe because that's what animal had, and here we have a speak. Let's run this, and we see here that it doesn't have any issues inheriting the methods. This is a very important concept of inheritance. If a child class does not have a certain method or attribute set up of its own, Python will look to the parent class. So in this case, when we created dog1, Python used the init method from animal. When we call describe, Python uses the describe method from animal. When we speak, Python uses the speak method from animal. That's already useful to us because we created a more specific class, dog, without duplicating all of the code that was already in animal. The value of inheritance becomes clearer when we imagine not just one child class, but maybe several related ones. Maybe we want a dog class, a cat class, a bird class. All of them are animals. All of them might need a name and an age. All of them might need a describe method. If we did not use inheritance, we'd end up writing the same init logic and the same shared methods in multiple places. That repetition makes code harder to maintain. Let's make dog a bit more specific. Right now, when we call speak on a dog, it says Buddy makes a sound. Sure, it's technically fine, but it's a bit too general. A dog does not just make a sound. We know that a dog can bark. So let's redefine speak, the speak method inside dog. Let's jump up here, and we'll define our own speak method here. And it'll take in self. We can even pull the code from here. Oops. And here we can change it to the dog barks. Now dog will still inherit from animal, but now it has its own version of speak. Now we can test this again. What should we expect to see? We see that it still inherits the describe method from the animal class, but now when we call speak, it calls its own speak method right here. And that concept is called overriding a method. Overriding means a child class replaces a method it inherited from the parent with its own specific version. That's another major reason why inheritance is useful for us. You can keep the shared parts from the parent, but we can customize the parts that should be different in each child class. For fun, let's create another class called cat. And I'll basically be the dog class right here. So just copy and paste this. And we'll have it be meows. And we can create it in basically the same way. Have our cat called Whiskers. And our cat, let's say, is 1 year old. And this will be stored in a variable called cat1. We see that it works. Now, both dog and cat inherited the same structure from animal, but each one has its own version of speak. Speak here, Prince will bark, and the cat will meow. So far, the child classes only change behavior by overriding methods, but child classes can also have extra attributes that the parent class does not have. For example, maybe every dog also has a breed. The parent animal class does not know anything about breed, and that's something more specific to dogs. So now we want the dog to keep the inherited name and age, but we will also want to add an additional breed attribute. And here, all we need to do is go up here, we'll define another constructor within class dog. And we can use basically the same structure here, but now instead, we're going to also pass in a breed parameter. And we'll just define self.breed here is equal to breed. This way will work, but it's not completely ideal. Why is that? Because we're rewriting part of the code. So name, age, we have self.name and self.age already. That's just duplicating code. What we can do is reuse the parent's init, then add only the new child-specific part, and that's where the super method comes in. So here, we can just change these two attributes right here to super, parentheses, and then dot. Get the method, and then name and age, and now here, we have referenced the init from the parent class. This goes up to a parent class, and then this gets the init from the parent class. And now we can add our own attribute here. This allows a child class to extend the parent class's behavior without copying and pasting the parent's code. Now, let's test this version. Say we had Buddy, and let's say he's now a golden retriever. Now we're curious about what his attributes are. So dog1.name, dog1.age, and dog1.breed. And now we run this. Now we see that the dog class has instance attribute of Buddy, 3, and Golden Retriever that is exclusive to only the dog class. And we see that the methods still work. We can do the same thing for the cat class. Let's pull our method from the dog class and let's put it into the cat class. And instead, we're going to be interested in whether or not it's an indoor cat. And this will be a parameter that's either true or false, because if you're an indoor cat, then you can't be an outdoor cat. If you're an outdoor cat, then it doesn't make sense that you're also an indoor cat. And now we can get the init method from animal, and here we can set indoor is equal to the parameter indoor that we pass in. And now we can adjust our code down here to create a cat object that is indeed an indoor cat. And we can verify this as well. just print indoors to save time. We can run this, and now we get true. And that's what we expect. The cat-specific attribute is added in the child class, and that's the balance inheritance gives us. We can reuse the same structure from the parents and add or modify what is specific to the child. One useful way to think about inheritance is with an is-a relationship. So, for example, a dog is an animal. A cat is an animal. A bird is an animal. And that's why inheritance makes sense here. The child class should be a more specific version of the parent class. And that's usually a good sign that inheritance might be appropriate. If the relationship does not feel like an is-a relationship, then inheritance may not be the right tool for you. For beginner examples, this parent-child relationship is usually a good way to understand the concept. The main idea in this lesson is that inheritance lets one class build on another. A parent class will hold the shared attributes and methods, while a child class will inherit those shared parts and can also add its own attributes, define new methods, or override inherited methods. In our example, to sum it up, animal was the parent class, and we had two child classes, dog and cat. We inherited the describe method from animal. We overrode speak in the child classes. And then we referenced the animal class using super, where we reused the parent's init. And that's what I wanted to cover in today's lesson. As always, let's do our git workflow, git add, lesson 12, and git commit lesson 12. Now we'll push to our course repository. Thanks for watching, and I'll see you in episode 13 of my Learn Python series.